Okay, we've got a decagon with sides of 4 centimeters. I'm going to draw one triangle, which I'm going to actually just imagine if I had a little, I'm going to draw this over here on the side. Imagine if I had a little decagon over here. Okay, whatever. I'm going to be drawing just one of these triangles that goes from the center right there to um, each vertex. These are consecutive radii, they call them. Okay, and essentially we've got these consecutive radii meeting up with a side length. Okay, so what do we have for the measurements? Well, they already told us that the side length is 4. And we know that if it's a decagon, there's 360 degrees in a full rotation around the center. This is 1/10 of that 360 degrees, or 36 degrees. We know that that's 36 degrees. Okay. Now we're going to draw an apothem. Okay. And that apothem, which we will call A, and we're going to solve for in a second. Now what we've got is that 36 degrees is no longer a 36-degree angle because it's cut in half. So what we're talking about now is just one side of this. Half of 36 is 18. And then we're only talking about one side of the bottom here. So that'll be 2 centimeters. Okay. So we've got this kind of half triangle here. Like that. Okay. All right. And that's equivalent to, up on our little tiny guy right here, it's that triangle right there. Okay. So how do we figure out what the apothem is? Well, we can use trigonometry. We have the opposite side 2 and the adjacent side A. So trigonometry says opposite and adjacent uses tangent. Tangent of 18 degrees equals opposite over the adjacent, in this case, the apothem length. Okay, and we know our rule that allows us to switch these. So then we can say the apothem length is equal to 2 divided by tangent of 18. Okay, and so I'm going to calculate that out. I'm going to say tangent of 18 0.325 approximately. So 2 divided by 0.325, about 6.115. I'm going to keep that in the calculator for a second and use it. When I fill out the rest of the formula, we say that area of the entire decagon will be, oops, got this super nice formula, which is 1/2 the apothem length times the perimeter. Okay, so we've got 1/2 times 2 divided by tangent of 18 times the perimeter. And if it says a side length of 4 and it's a decagon, that means that there's 40 units in its perimeter. So we do 1/2 times 40 times the 2 divided by tangent of 18. Okay, so when we do that and calculate it all out, we get approximately 123.115, and they want it to the nearest tenth, so we need to round it to there. We're looking there. Is that 1 5 or higher? No, it's not. So that one other one stays a 1, so we get approximately 123.1 centimeters squared. And let's look for that answer down the bottom. There it is, A. All right, a dodecagon with a perimeter of 108. So like I did before, I'm going to draw, if we had like a dodecagon over here, Okay, I'm going to draw from the center, I'm going to draw two adjacent radii to form that angle, okay? And what I want to do is I want to find out what the apothem length is, but I also want to know what the side length is. It's a dodecagon, and I like to remind kids how to remember it like this. Do comes from like dos, do, and deca is 10. So we've got like 2 plus 10, do deca. And 2 plus 10 is 12. It's a 12-sided figure. Okay, so we're going to take this 108 perimeter, 108, and we're going to divide it by 12 to find out what the length of each side is. And when we do that, we get 108 divided by 12. So side length of 9, so that's got a length of 9 right there. So if I recreate that triangle down here, okay, and then draw an apothem, then that side of 9 actually really turns into a length here of 4.5. Okay, just from the middle to the edge from there to there. Okay, now what else do we know? We can find out the angle. If it's a dodecagon, we're going to take the 360 degrees that's in a full rotation and divide it by 12, and we get 30 degrees. That's going to be this whole pink angle right here. Okay, but we really want to know only half of that. So what's half of 30? Well, half of 30 is 15. So we know then that this angle in here is 15 degrees. Okay, so now we've got a triangle that looks like this. We've got the apothem. We've got this side length of 4.5. And we know it's a right angle. So let's fill it in. 4.5. This is 15. And we can use, if we want to find the apothem length, we can use tangent, opposite and adjacent. So we say tangent of 15 equals the opposite side, 4.5, over the adjacent side, x. Our rule allows us to switch what's on the bottom with what's over there. So we get x is equal to 4.5 divided by the tangent of 15 degrees. That's what the apothem is. Okay, so I'm going to erase all this. Excuse me while I erase for a minute. Thanks. Okay, and I'm going to do it over here. We're going to use the formula that says the area of a polygon is equal to 1/2 the apothem length times the perimeter. And therefore 1/2 times, we figured it out, is 4.5 over tangent of 15 for the apothem times the perimeter. Well, they told us that the perimeter was 108. Okay, so let's do it. Let's calculate all this out. We do 1/2 times 108 is 54 times 4.5 divided by tangent of 15. And we get 9.06888 approximately, or 906.9 centimeters squared. The area of the whole thing. Where do we see that? There we see it right there. So the trick with this is to find the apothem and then use that formula for finding the area, 1/2 apothem times perimeter. Okay, pentagon with a side of 10. I'm going to sketch this out. And we know it's got a side of 10. meters. And if we took this center and we did that, okay, we would find that that 360 degrees gets broken up, and this is a 72-degree angle in there. However, when we drop the apothem down, we split that and it becomes a 236-degree angle. So we're going to use the 36-degree angle, and we have a right angle there. And if we had a side length of 10, then this side length right there is now 5, and we can draw that triangle like that. Okay, and what do we know? We know that's 36 degrees. This is a side length of 5, and if we wanted to find the apothem, then we again would use trigonometry and particularly tangent. Tangent of 36, tangent's opposite over adjacent, the opposite side is 5, the adjacent side is x. And switching them, which we're allowed to do to isolate x, we get x, which is the apothem, is equal to 5 divided by tangent of 36. So then we can use all that in our formula. If it's got a side length of 10, then it's got a perimeter of 50. So we can say area equals 1/2 the apothem, 5 over tangent of 36, times the perimeter of 50. We can do this all in our calculator. Let's see. And I calculate 172.04. So I'm going to write it as approximately 172.0 meters squared. And even though they didn't show it out to the tenths, that's what you're seeing here down there at D. Okay, this is a hexagon with a side of 6. I'm going to sketch this hexagon out. I'm going to do it kind of big because I want to be able to draw right in it. Okay, if we had this central point here and connected all of the radii, right, from the center to the vertex, we're getting 60-degree angles in there. So when you drop the apothem straight down, form a 90-degree angle, you also split this up into a 30-degree angle. And 30, 90, this one must be 60. So if we have a side length of 6, then that means that this length right here, half of the side, which is the small side of the 30, 60, 90 triangle, would be 3, exactly half of that. So if that's 3, then the apothem is 3 root 3, because that's what you always do with the short leg of that special 30, 60, 90. You multiply it by root 3 inches. And now we can use our formula. Area is equal to 1/2 the apothem length times the perimeter, and 1/2 the apothem length is 3 root 3 times the perimeter, which is side length of 6, and it's a hexagon, 36. So let's multiply all that. Let's see, just give me a second here. Do the square root of 3 times 3 times 36 times 1/2, and I get 93, approximately 93.53, so 0.5 rounded to the nearest tenth of an inch. B. Okay, pentagon with a radius of 8. Aha! we're going to do what we learned from this amazing trick, which is this. If we know it's got a radius of 8, and we do, and it's got this side of 8, if we know this in angle in between it, this angle right here, we can use the side angle side area measure to find the area of that triangle and then multiply it by 5 because there is 1, 2, 3, 4, 5 of them in there. Okay, and we do know that because if it's a rotation of 360, then that angle is 72. Okay, so then we can use the formula for area of a small triangle is equal to 1/2 times BC sine A, which is essentially saying 1/2 times the length of one side times the length of another side, which are both the same, and then times the sine of the included angle, which is 72. Okay, let's do that on the calculator here. Oh, and okay, let me see. 0.5, actually, let's do sine of 72 first. Okay, times 0.5 times 8 times 8 equals 30.43, and that's for one triangle. We need all 5 of them, so times 5, and I get 152.16, or approximately 152.2 centimeters squared. That is D. Okay, so let's draw the square first. This will be helpful to do. Okay, and why did I want to draw the square? Okay, if we had a radius, which is coming here from the center and going out, and they're telling us that that has a radius of 16 meters. Okay, well, and they're asking us to find the area to the nearest tenth. Well, we already learned a technique, and this is the cool technique we learned this last class, which is if we had two radii like this, we would know that because the whole triangle, the whole thing from here all the way around measures 360, then, see if I can erase that without erasing everything, then one section of it between any two radii is 90. So we know that this is 90 degrees. Why do we care? Well, because we also know that this is 16 because it's the same. And we have this cool formula that we just learned, which is you can find the area of this little triangle. What we're finding would be then the area of this triangle here, okay, by saying the area is equal to 1/2 B times C times sine of A, the angle in between them. And by the way, we would end up getting 4 of those triangles, 4 of these purple triangles, if we extended these radii out all the way. You can see that there would be 4 of those triangles. So we can then take that number times 4 and we get the proper area for the whole square. So let's just do that. Let's just do 2 times, sorry, not 2 times, 4 times, because there's going to be 4 of them, times 1/2 times, what is one side length? 16. What is the other side length? 16. And then the sine of what's the angle? The angle is 90. So the sine of 90. And let's type all that into our calculator and let's calculate what we get. What we get there is 512, and the units are meters, so we get meters squared. It is not it is not an approximation because the sine of 90 is exactly 1. So we get an exact number, 512 meters squared, and that is A.